Okay, so I, excuse me, I did find the schematic. Um, this is a schematic of the 822 rather. What I've got here is the 822E. E stands for export, and the primary difference is in the power supply wire, how it's fused, how it's handled coming into the radio. The North American standard's a little different than the European standards, so the difference in the E is just going to be down here in the power supply and nothing of too much consequence at all. Everything else should match. Again, it's a German radio. Everything's in German. I was looking at the alignment instructions. They're all in German. So, pretty challenging to try to figure out where that is on the schematic. And it may very well come down to that. But there are some other things here. Now, I've thought some more about how did this get knocked out? And how did this wire get broken? And my conclusion is, coupled with the fact that I found a couple of these loose here, is that somebody has performed an alignment on the radio, doing it from above, and they pushed the tool, the alignment tool, down from above, and in doing that, they've knocked this out and somehow knocked this wire off. I can only guess by pushing a tool through that hole. So, two things we can do. First, I really think we need to put this back in the hole properly. Whoops, sorry about that. I'm going to need both my hands to do this. So I'll set the camera here. Oops. And I'll see if I can put that back in the hole without breaking any of the wires while I'm doing it. And of course, what's going to hold it in there is nothing. Oh, you can see some glue up there. I think I better put some glue on this. So I'm going to use a wholly inappropriate glue here to do this. It doesn't take much to hold these in place. And I would guess that what happened here is it put the tool in and yeah, let's think about this a little more. He put in his tool, it tried to turn this, and instead broke the whole thing free from its holder because this is frozen here. Yeah, not good to use a metal screwdriver. There we go. Okay, so didn't take much to loosen that. But I was going to say that probably just applied too much force from above, rotational force, broke it free and then pushed it down in the radio. And at that point, the guy fixing this either knew what he had done or no clue. Yikes, a little too much glue there. In you go. Well, maybe you can never have too much glue in a situation like this. There we go. Okay, so I think the wires remained intact, which is good because they're very, very fine wires. If they break up near the coil, it's not easy to fix. So now we're back to the missing wire. Not exactly missing, but the wire that doesn't know where it wants to go. I'll just be right back in a second here. just wanted to grab my oh so handy pliers, which I use an awful lot. Man, it's a wonderful tool. I've had this a long time. So what I'm going to do, I already know this isn't loose. So this wire can only range so far. Okay, assuming, now I mean lots of assumptions. It's closest to where it should go already. It means it would go there or there. It's not likely to go there. It's not likely to go in there. I could swing it around. I mean, it could go in any one of these spots, but again, it's not terribly likely. It's most likely going right there. Could be going there. So one of these two guys here. Now I've examined both of them very, very closely using the magnifier. Now what I'm looking for is evidence of where the wire broke away. I can see some remnants of the wire. It almost certainly broke flush with the solder. So it's tricky to see the spot. Now there's a couple of spots, if you like, on these connectors, on these solder points, and that's because all the tails, the component tails, have been cut, and you can see that. If you look closely, you can see where they came from. And you know, it looks like this little wire, but there's a spot on the back of this one which lines up perfectly with this wire. Right there. That's, you know, if you want to play a guessing game, that's probably the best guess. Let's see if I can get it on the magnifier here for you. Not terribly easy to guess. Okay, now I need a pointer. I'm going to show you this. That's about as good as it's going to get. Yeah. Okay. The point I'm talking about is right there. A little tiny bump. You can see it right there where I'm pointing. And that appears to be where the wire has come off. And the wire quite naturally heads right to that spot too. Still a bit of a mystery as to how that would come off. I wonder if, when this piece came loose and fell out, if it didn't pull this wire with it. Now, from the way the parts were kind of laying in here, this wire is up out of the way. And it raises two interesting questions. Did it come down around like here's its brother wire right here, the other part of it? Was it also down there, and when this came out it pulled it off? That would raise the question as to how it got bent way up here. What force would bring it up there? So we're really left with a mystery here. I guess I could play a guessing game all day about how did this come about. I probably have the story on this guy correct. It was knocked out by somebody pushing down a tool from above. It is only a guessing game though, isn't it? So I'm going to take another close look at that, because my alternative is to figure out where that wire is on the schematic, and there's nothing easy about that either. So I could find some physical evidence here. You know, it's very convincing that that's the spot that it came from. Now that I see it like this. Now, he might have been seeing it this clear too on your screen when I was using the magnifier there. It would almost look like this variable capacitor is in parallel with the coil, and that makes some sense, doesn't it? So they're both variable. Got anything like that on the schematic? So here's a bunch of coils, variable coils, or adjustable coils. Another whole whack here. Here's a set here. And I'm looking for a variable capacitor around them. Oh, here's some. There's some variable coils here. Another one there, and then here's some variable. Here's a variable capacitor. Yeah, you know, there's coils here. Variable capacitor. You can't even see what I'm pointing at here, can you? Oh, there's a whole bunch of them here. Coils, capacitors. Okay, so yeah, it's one of those. Now we'll come at this from another angle. Let's suppose I say, okay, that wire came from that spot. Let's reconnect it and see what happens. What could go wrong? Let's look again at these coils, all these different coils. Well, some of these are just from the antenna. So I don't think a lot would go wrong if I wire this wrong. Here's one. See, this is connected to the plate of this tube. There it is, connected right to the plate. No, there's a capacitor in there. But there's a good chance this coil carries plate voltage and plate current. So I could do something foolish. You know, I could operate the set and test the open end of that coil and those components there. I can have the set operating and make the connection briefly. That can be exciting, rather than solder it back in, turn it on, and hope. So why don't we operate it and make a few measurements with it open like that, because open is probably not hard on the radio at all. Shorted would be hard on the radio, but that's not what we're dealing with. Yeah, I think that's our option. Now, in order to test that for voltage, I can just use my multimeter on it, easy enough. Is there a test I can perform that will identify where the wire goes? And I think the short answer to that is no. No, there isn't such a test. Not that I know of. Is there a test I can perform that will help me identify the coil? Well, yeah, I would have to. So I would say this. We run the set, do some voltage tests on the open wire and around here, build up our courage, connect the wire to where we think it should go, see the effect. If the effect is not what we want, in other words, if the radio doesn't start working perfectly, or much better, then disconnect and we'll have to figure out where that coil goes. You know, it looks almost like there's 3 coils in there. There's 3 separate windings. Here, here, and here. But I'm not sure these lower 2 could be the same winding, just wound that way. Okay. Now to temporarily connect that wire, probably the best thing is grab it and touch it. And if we get a fairly, any kind of positive result, we can go ahead and solder it and try again. Okay, I think we're ready to start them up. So if you're like me, you'd rather be far away during this process. Okay, what happens if I put you way back there? You can also run the set on current limiting, which will reduce the supply voltage and just reduce anything bad that might happen. Starts off. Okay, it's plugged in. Now, better clear out the holes. The volume is here. Volume is down. And the FM button is the last big button, so okay, I think we're set. Powering on. Okay, no lights, so the bottom button. Okay, so it's lit up inside. I don't think you can see that. We'll give it the... Let's see, we're at 80% aligned voltage now. Just watching this meter here. And now it's beginning to drop as plate currents begin to flow. Down pretty low. About 75% of full line voltage. That's probably not enough to operate the FM section properly. So we might have to, here, let me give it another light. Okay. That brought it up to about 90%, so it should run. Let's give it a little volume. Okay, you should be able to hear it. Let's tune it. Tuning's weird. Okay, we'll check those voltages like we planned. Check 4 voltage. Ground. Okay, so the lug we're thinking of connecting it to has no voltage on it. Well, you know what this could be too? This could be somebody discovering this coil is open. No reading at all on the meter. Let's get something on this meter. There we are. Okay, just convincing myself my meter's working. So there's no voltage on either end of this coil. Let's go on what I think is the other end of the coil. Good show, nothing. Well, I think we're safe to connect it. Check the volume. Okay. Volume is, you have to connect it and then work the volume. Okay, volume is up where I would expect you would hear the radio. Here we go. Everybody ready for some excitement now? Well, no excitement there, right? Let's go up a little higher. Ready to jump. Wow, that's pretty disappointing. Okay, so another possibility here is that there is a open somewhere in the IF, and what we were seeing was someone else's attempt to find the open circuit. And they had pulled this coil out for some reason, and then we're checking it. They removed this wire as part of the procedure for checking it, and gave up. This is another possibility. Wouldn't, well, it's another possibility of how it got to be the way it is. Now, really disappointing here. This wire didn't do anything. Let's grab the actual metal part of the wire. Well, that's kind of disappointing, isn't it? So, it's in line with this switch. Let's oh, that's interesting. All the buttons are sticking now. No. Oh yeah. This button I just pushed is the one that's in line with all these parts. So let's bring you up a little closer here. Okay, so I now have it on a different band. I think it's on the AM band, I'm not sure. Let's turn it up. That's full. Not hearing anything at all. Let's just take a look and see what we actually have pushed here. Yeah, that's the AM button. Depressed. Yeah, I'm depressed. It's not the button that's depressed, I'm depressed. Well, I got so excited when I found that wire. Now let's try it again. Volume down, but up a little bit. Ooh, let's check for some voltage here. Because I've changed the switch setting, maybe things are different now. There's no voltage on any of this. No, I see no voltages anywhere here. So let's try that connection thing again. The volume is up just a little bit. Oh, that made a difference. At least I thought it did. Let's turn it up a bit more. Thought I heard something there, but huh. Okay. We're on AM. It has an AM loop antenna. Some of these have a switch incorporated in the antenna. We have an antenna rotating system I'm turning right now, and at the limit on some of these radios there's a switch, and when you reach the limit it throws the switch and the radio now will only receive from an external antenna. This one doesn't seem to have such a switch. So our volume is full now. Phooey. Well, you know what? We don't have this thing on full voltage. Let's put it up on full voltage. Volume down. Power up. Just in case the voltage was too low to activate one of the tubes, an oscillator, or anything like that. Okay, let's turn it back up. Let's tune it, see if we can find a station. There's some of my shop noise. It's so quiet you can't hear it. I'll have to use some of the noise instead of an actual. Okay, let's get some of that noise. Any signal's better than no signal. Volume's up full, so if this thing comes fully to life, this will blast me right out of my shop. So turn it down. We'll make that connection I think should be made. Not leaping to life, is it? A little more volume. I can hear the noise signal now. It's very faint. Well, it's better. Either one of these. What's that tell me? Neither one of them is the right one. Oh, a very disappointing time in the shop here with this. Huh. Well, I'm a little stuck at this point on what to try next. You know what? To me, more and more, it sounds like a defective coil here, and that this was testing stuff, incomplete. I think I'm going to have to try and test the continuity of these coils next. I think that's what we got to do next. So shut the power off. And we'll do some coil testing here. The coil's got low resistance continuity. We're going to hear that. So the first one we'll do is the one with the loose wire. Let's say one wire goes here and one goes here. Okay, I did see a reading just now. Let's see if I can get this on camera. There. That was enough to prove it. Very hard to make a contact. So the coil with the loose wire is has continuity. Now, trying this guy, this coil, it's going to be a little tricky. The wires have slightly different sizes. The skinnier one. So these two appear to be the same wire, same size. So although my eyes are going buggy here trying to, I think we're talking about here. That's one end. Oh man. The other end looks like here. There we are. Okay, so that's good. That's continuous. Now, so that means the other two are the other coil. So the light one, holy smokes. Okay, light one goes there. Oh boy. I think there's only two coils on here. Yeah, that's the other one. That's the other coil. Okay, so one goes here. The other fine wire goes, it looks like it's simply these two here. Okay, if I've done it right, we've proven the continuity in two of the coils on here and one of the coils on here. If there's either two or three coils on this one. My hand's really blocking your view here, isn't it? Well, I think this might be a good time to take a little break and ponder the situation for a bit. Let my brain cells talk to each other for a while and see what my next move is on this radio. I'm a little bit stumped. Thanks for watching so far.